When we think of an apex predator, our minds immediately go to the massive hunters of the animal kingdom, creatures like lions prowling the savanna or great white sharks patrolling the ocean. Yet, in reality, these famously terrifying beasts actually fail to catch their elusive targets more than half the time. Compare that clumsy track record to a delicate, seemingly fragile insect resting quietly on a blade of grass in your backyard. This chart comparing hunting efficiency shows the lion's sub-50% success rate eclipsed by the dragonfly's 95% strike rate. In practical terms, once a dragonfly locks onto a mosquito, the mathematical probability of that prey surviving drops essentially to zero. How exactly did evolution engineer a tiny, paper-thin insect to mathematically outperform every other hunting machine on Earth? This anomaly is rooted in a body designed like a highly optimized biological drone rather than a simple Barden insect. Their unique biomechanical advantage lies in a remarkable ability to articulate all four of their wings completely independently. This localized control enables a specialized aerodynamic repertoire, allowing them to hover perfectly in place, fly backward, and change direction instantly. This complex propulsion system also generates massive thrust, pushing their top flight speed to 35 miles per hour. Speed requires precision targeting, which is handled by massive compound eyes that wrap around and cover nearly their entire head. Because of this anatomical layout, their brain processes visual stimuli at such an extreme rate that the frantic, erratic movements of their prey are perceived in slow motion. The combination of instantaneous multi-directional maneuverability and hyper-fast visual processing means that once a target is acquired, it is physically prevented from escaping the flight path. This predatory perfection is no accident. It is the end result of roughly 300 million years of evolutionary research and development. The design traces back to a prehistoric ancestor known as the Meganeura, which hunted during the era of the dinosaurs. Looking at this minimalist size comparison chart, you can clearly see the giant Meganeura matched the wingspan of a modern-day hawk, towering over the silhouette of an average human. The extreme environmental pressures and fierce competition of that ancient era served as a relentless crucible, forcing the species to refine and perfect its hunting mechanics simply to survive. The passage of millions of years did not dilute the predator's lethality. It merely miniaturized a prehistoric hunter into a hyper-efficient modern biological weapon. The world's greatest aerial predator actually begins its life nowhere near the sky, but entirely underwater. During this complex biological phase, known as the nymph stage, it lives as a strictly aquatic predator for up to 5 years before ever taking flight. Rather than hunting other insects, it stalks the murky depths to prey on much larger targets like tadpoles and small fish. They ambush these larger targets using a terrifying, rapidly extendable jaw that shoots forward to trap their prey. Mastering this brutal aquatic battleground acts as a strict evolutionary filter, guaranteeing that only the most resilient, perfectly adapted killers survive to eventually grow wings. 300 million years of constant refinement, a brutal amphibious life cycle, and the engineering marvel of independent wing articulation have resulted in nature's most efficient design. That delicate garden insect resting on your patio furniture is actually a hyper-evolved killing machine operating in silence. Which raises the question, what other ancient, highly evolved survival machines are secretly operating right now in your own backyard? Subscribe to the channel to uncover more of nature's most extreme biological designs.